The last of the three types of equations is the one that is called the vertex form. Okay, these are in the form y equals a times the quantity x minus h squared plus k. So the key to understanding that this is in the vertex form is the fact that you have a binomial that is being squared, and often, almost always, I mean, if there was nothing written, it would be plus 0. But majority of the time you'll have a plus or minus out here. But the key to understanding that this is going to be the vertex form is the fact that you've got the binomial being squared. Sometimes you'll have a coefficient that is not 1. Many times you'll have the plus or minus. The thing is, in the template of the vertex form, this says look at h and take the opposite of it. But this is the vertex form, and so the easiest thing to find given this equation is the vertex. Okay, so if I have the opposite of the quantity x plus 2 quantity squared plus 1, what I am looking for as far as the vertex, because this is the vertex form, so find the vertex first. The vertex is going to be located h comma k. Well, here's h, here's k, but the template says take the opposite of h. So I look at the positive 2 and I take the opposite of it. But when you decide what k is, this does not say take the opposite of k. This just says take k for whatever it says. Okay, so it says on this problem that k is equal to 1. So there is the vertex at negative 2 comma 1. Negative 2 comma 1. Now, if we know where the vertex is, we also happen to know the line of symmetry, because the x-coordinate of the vertex happens to always be the line of symmetry. So here the line of symmetry is going to be x equals negative 2. Okay, so there's our vertex and there's our line of symmetry. We also need to find the x-intercept and the y-intercept. Okay, to find the y-intercept is really easy, right? Because when we find the y-intercept, we know that the value of x is equal to 0. So we're going to have to change this into the standard form, right? And if you change this into the standard form, then the value of c is the y-intercept. This is another way of finding the y-intercept. We know that we are on the y-intercept when x equals 0. So if I go ahead and substitute a 0 in for here and simplify, then I get the y-intercept. Okay, so I'm going to have the opposite of 0 plus 2 squared. So this is going to be 2 squared. The opposite of 2 squared, which is 4. So the opposite of 4 is 1. Okay, and then plus 1, that's going to be negative 3. So the y-intercept is at negative 3. That just could be an equal sign. Okay, and if I have a y-intercept of negative 3, and this is the line of symmetry, then I have a mirror image. So this is 1, 2 units away, and I would go 1, 2 units away on the other side. Okay, and then to find the x-intercepts, I know that y is equal to 0. So essentially I have 0 equals the opposite of x plus 2 quantity squared plus 1. But the way I'm going to figure out the x-intercepts is to use the quadratic formula. And in order to use the quadratic formula, I have to know the values of a, b, and c. And if I have to know the values of a, b, and c, then I cannot use this form. I have to change this to the standard form. So I'm going to change this to the standard form. I am going to have x plus 2 squared. That's the first thing I do. Right? I don't take the opposite first because that's like multiplying a negative 1. Order of operation tells me to go through and do exponents first. So x plus 2 quantity squared really means x plus 2 times x plus 2. So I have this times this and I have this times this, and then I'm going to have a 2x from that, and I'm going to have a 2x from that. So adding those together, I have a 4x. But I'm supposed to take the opposite of that. Oh, and don't forget that you have to bring that plus 1 down. Okay, so if I take the opposite of this, I'm going to have the opposite of x squared minus 4x minus plus 4. Oh, I'm sorry, minus 4. I'm taking the opposite. Hello. And then plus 1 there at the end. So I'm going to have y equals the opposite of x squared minus 4x minus 3. So this is the other way to find the y-intercept, right? I can go through and change it into the standard form, and the value of c is the same as the y-intercept. I think I'm going to kind of scoot over here. I'm getting into space for number 9. So I have a equals -1, b equals -4, and c equals -3. I am going to have x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. The first thing I'm going to do is the b squared minus 4ac. So that's going to be b, which is -4. So -4 squared minus 4 times a, which is -1, times c, which is -3. -4 squared is 16. That -4 times -1 is +4. +4 times -3 is -12. So that equals 4. So then when I take the square root of that, I take the square root of 4, which is 2. Man, I'm really running out of space. Okay, I'll have a little more space over here. So I'm going to have the opposite of b plus or minus, all divided by. So I'm going to have the opposite of b. B was -4, so the opposite of -4. Now all of this I just figured out, right? All of this is just 2, so plus or minus 2, divided by 2 times a, and a was -1, so 2 times -1. So it's going to be 4 plus 2, divided 4 plus or minus 2 divided by -2. So I'm going to have 4 plus 2 divided by -2, and I'm going to have 4 minus 2 divided by -2. So 6 divided by -2 is -3, and 2 divided by -2 is -1. So my x-intercepts are at -3 and -1. Okay, -3 and at -1. All right, there's that graph. Now we do it all again. Okay, so I'm going to have the vertex at the opposite of this, so that's going to give me -1, and face value of this says -4. That means my line of symmetry is going to be at x equals -1. So here's my line of symmetry, and my vertex is at -1, -4. Okay, I also need to find my y-intercept and my x-intercept. So one way to find the y-intercept is to say that x equals 0. So I would have y equals the opposite of 0 plus 1, quantity squared, minus 4. The opposite of 1 squared, minus 4. 1 squared is 1. The opposite of 1 is -1, minus 4. So the y-intercept is at -5. Well, this is a line of symmetry, so I have one point over here, then I have its mirror image. The other way, same length away. This was 1 unit, this is 1 unit. Now, obviously, if this is the vertex, this is either the max or the min. And if the y-intercept and its counterpoint are below this, the vertex, then that must mean this is a maximum. If this is a maximum, then I'm never going to reach up here the x-intercepts. So I'm not actually going to even find the x-intercepts. What I can tell you right now is that if I did find and did the work for the y-intercepts, that when I got to the point where I did b squared minus 4ac, that would equal a negative number. Because when I take the square root of b squared minus 4ac, I would be trying to take the square root of a negative number. And I can't do that. So there are no x-intercepts. Alrighty, last one. Last one. Whoa, so much junk written I can't even see where the problem is. Y equals 2 times the quantity x plus 3 squared plus 2. Okay, so my vertex is going to be at the opposite of this and the face value of this. So my vertex is at negative 3 comma 2. Negative 3 comma 2. Okay, and my line of symmetry is at x equals negative 3. So right here I have a line of symmetry. Okay, so I'm in the process of finding the y-intercept. When I find the y-intercept, I know that the value of x is equal to 0. So I can either change this into the standard form, which I might have to do anyway to find the x-intercepts, or I can say, well, I know to find the y-intercept, the value of x equal to 0. So I could substitute the 0 in for this, and I would get 2 times the quantity 0 plus 3, quantity squared plus 2, which is going to be 2 times 3 squared plus 2. And 3 times, order of operations says 3 times 3 first, so that's going to be 9. 9 times 2, which is 18, 19, 20. So the y-intercept is at 20. Okay, well if you look at this, 20 is going to be way up here, right? That falls off my graph. However, what I do know is that if my y-intercept is way up here, and this is the line of symmetry, and my y-intercept is way up here, and because of the line of symmetry, I have a mirror image that would be way over here, that this is going to be a graph that opens up. If I can't put the y-intercept on here, and I know that there are no x-intercepts, right? Because the graph is going to look something like this. How am I going to graph that? Well, if this is all I have and I can't get x-intercepts because there aren't going to be any, and I can't have a y, I'm not going to go like this, 12, 13, 14, 15, 16, right? What else can I do? What I can do instead is look for more points that I can plot that are close to the line of symmetry. So the line of symmetry is at negative 3. What I'm saying, let me scoot my paper over, is come up with some values for x, use them as inputs, and you will be able to figure out y. Now, I think I will try, well, I'm not going to try 0, right? Because when x equals 0, I already know that y is going to equal 20. That's not helpful. But here's my line of symmetry, so I'm going to go ahead and try x equals negative 2. I'm not going to try negative 3 because when x is negative 3, I already know that y is 2. So I'm going to try negative 2 and I'm going to try negative 1. So what I'll do is I'll say y is equal to 2 times negative 2 plus 3 squared plus 2, and figure out what that is. See if that number is helpful. And also I'm going to say 2 times, using this as an input, negative 1 plus 3, quantity squared plus 2, and see what I get when I come up with that. Okay, so I'm going to have negative 2 plus 3, that's going to be 1. 1 squared is 1. 1 squared is 2. 1 squared is 1. 1 times 2 is 2. and 2 plus 2 is 4. And then over here, I'm going to have negative 1 plus 3. That's going to be 2. 2 squared is 4. 4 times 2 is 8. 8 plus 2 is 10. Okay, so I know that I have the point negative 2, comma 4. So negative 2, comma 4. But what do I also know? That this creates a mirror image. So I also have this point. And that's really enough. But I've already done this one. I might as well continue. When x is negative 1, y is 10. So at x is negative 1, y is 10. And because I have a line of symmetry, this is 2 spaces away. So 2 spaces away on the other side is its mirror. Looking a little bit V-ish. Don't forget, it needs to look more like a U. Okay, there's that one.